Previously, we worked on the hot reload and the metal shader hot reload. So all this basic stuff, the architecture that's underlying everything. Now, this time I'm going to show a little bit of how apply the ECS, so Entity Component System for rendering, a mesh library, and a texture library. They have similar behavior, similar like a similar architecture, and basically we need to make sure that we load things at the right time, and then create like multiple meshes can be in the same buffer, multiple textures as well. So let's go into that. Here, the first thing I want to show is like created two types of meshes for now. I'm just adding to the library. This is probably going to change later as how you declare the available meshes. For now, there's a triangle and a rectangle and a debug texture. So the triangle mesh is very simple. So it's just 3 vertices. And the structure here is always adding normals and UV for everything. And the indices. So first vertices, the first vertex, the second vertex, and the third vertex here. Cool. For rectangle, now we have 4 vertices, but we need to create 2 triangles to make a square or a rectangle, if you will. And that's how we do it here. So that's the order of the vertices that will be rendered. When we're working with meshes, it's a good idea to compile all of them in a buffer as many as you can, so you don't have to keep like adding multiple buffers. So if we can create one buffer, then in this buffer we're gonna like take a slice of the buffer for each type or each mesh. We're talking about static meshes here. And the way I did this one is, so first we have our vertex data that stores all that information, and then the mesh data, you have all the vertices and indices for each mesh. This is a temporary data structure that will just be used while loading everything into GPU. The abstract mesh class, so this is what the triangle and the rectangle will override. And then we have mesh descriptor that shows like how where in the buffer each of those meshes are, like what is the offset of the vertex, what's the count of vertices. In the mesh library, it stores everything, like, and then it has this big buffer of vertex data and all this. So this is what the GPU will receive, like basically these 2 buffers here. So the mesh library is just mapping the descriptors. Every time we add a new type of mesh, it creates a new descriptor for that mesh, and it's tagging the ID. So every time you want to use a triangle, you just have to point to the triangle ID. For instance, triangles not going to be used a lot. Mostly it's going to be rectangles for the sprites, and eventually I'm going to make like a GLTF loader, or like a GLTF mesh, or types of mesh that loads a type of file, right? And here I'm just describing like how to transform the data, all those abstract meshes, into one mesh library data that's going to go to the GPU. It's this one caveat here where, because we are adding everything in sequence, if you look at the rectangle mesh, there's no way I can know like where in the indices this is gonna be. So I was starting from 0, so it's relative to these. Same here, indices are relative to the vertex data. But as I'm adding to the library, I need to use a vertex offset. So I need to start, if for instance, if we added the triangle has 3 vertices. the starting point for the new indices will be 3, right? Because it needs to offset the indices. Okay, then in the renderer, it's a little bit like more complex. So I check, this is the metal render only for now, but I hope I can translate this to other without too much trouble. Maybe OpenGL will be hardest one, but Vulkan and DirectX should be okay. So this would be happening every frame. Make sure that we have the latest library in case you add more in the middle of this process. Maybe we want to have some dynamic meshes that get loaded and removed. And so basically we reserve the memory for the mesh data, and we create the buffers, we put everything in there, we copy the contents into the mesh vertex buffer that's been created. And this is sending to the GPU basically. And then when you want to render, for every draw call that we add, and I'm going to show it in a minute, we just draw the primitives, send the index buffer, the offset, and oh yeah, and we get this from the descriptor from the mesh. So the way this works, when you want to draw a mesh, so when you want to draw a mesh, you can see an example here. So here we're rendering this, just the first one here, which is the triangle, right? And if we want to render another one, let's render the rectangle and build again. Yeah, now we're rendering both. So it adds a component, and that takes the idea of the mesh. And then it's pretty simple. This is the abstraction with the entity component system for the rendering layer. So in this part, I don't care about the render, how it's going to use it. I'm just describing what I want to see, what I want it to have as components. The system that renders is actually this one, right? So I get all the meshes, all the entities that have this mesh component, and for each one I will draw. I'll make this draw call. Cool. Textures are very similar. So we have the structure or the texture data, usually 4 channels, the size of the data, which probably can remove the size now. And the texture type, we can have cube maps, we're gonna have depth maps. So later I'll be adding more types of texture, if that's the place to have, probably. And the link to the texture that's gonna have the get data. So get data will be called when the texture is required, sort of a lazy loading. Same concept here. We add textures to the texture library, and then you can get it later if needed. So the way the metal render will handle this is the same. So if there was some modification, I'm gonna clear all my link. I have this map of textures here that I'm using locally to reference on the later. You can see where it's needed. And here I'm using the argument buffer to store, because I want to be able to send multiple textures in an array to the shader. And I hope I did this right, but that should be the case. So I have like multiple descriptors here of texture. So I get them, I will get the data. This is the place where it will be loading the data, or it's already pre-loaded it depends on how I want to optimize this, because it could create some frame rate drops if it's trying to do it in the frame. And also maybe I'll have to add some kind of a parallel fetching of data here. It would be especially interesting if we could use like remote files, like fetching stuff from like a web server or something like that. And so there's gonna be some kind of like status or the state of the texture, whether it's loaded or not, if we can use it or not, if we use some placeholder while it's loading. The rest is just metal specific stuff that is setting up the texture type and everything and placing the data there. So here I'm mapping every texture to my texture map there. And we use it a little later where I need to make sure that the encoder uses the actual textures here. So without this, the GPU is looking for this resource and it can't find, so it crashes. And I think this is pretty much it for this release. Next, what would be nice is to actually see those things in like perspective. So I need to add a camera. And the other thing that's interesting is creating now that I can have textures and meshes, create a sprite library. So the sprite is basically a mesh, a rectangle that has the texture coordinates to a place in a texture. So using like a mix of texture atlas, where you can have multiple sprites in a sprite sheet in one file in one texture, and then we just render them based on that. So the next one is going to be interesting to build the sprite sheet using both textures and meshes and link them together. The other thing that's important are like render instances. So an instance buffer. This is the way we use to render multiple sprites, for instance, or multiple meshes of the same type, and passing properties like where it is, like the transform. So the next ones, things are going to be more interesting moving forward. So this is it for this update. See you soon.